Hello, guys, and welcome to the continuation of our class on mean hypothesis testing. Just a brief recap. In our last class, we mentioned there are three types, and then we have treated one of the type, which is the one sample mean test. Today, we are looking at the other two, and then we'll jump into the practical section. Okay, mean hypothesis testing test sample mean test. Test sample t-test compares the mean of two measurements taken from the same individual, object, or related unit. These paired measurements can be represent things like a measurement taken at two different times, e.g. pre-test and post-test scores, with an intervention administered between the 2 points. Now, this paired sample t-test is when you are measuring the mean of a particular population at two different instances. Like this example here, in this case, you are dealing with one population, but you are measuring the mean. You are comparing the mean at two different instances. Are the mean the same? Maybe between, for the example here, a pre-test before a test was carried out and after a test was carried out. Maybe an intervention, maybe a student in English and you invited foreign students for one new program. Then after the program, you still give them the test again to compare their mean score before the test and after the test. So in this case, you are dealing with what a particular sample. That is what you should take home from this. The second example is a measurement taken under two different conditions. Completing a test under a control condition and an experimental condition. That means maybe a particular experiment, you did it under social condition. That same experiment, you did it under another condition. So you are working with the same experiment. So in that case, you use a paired sample mean test. So what do you compare? You compare basically two things. Number one is the paired population mean. Are they equal? And this is the second one. Are the difference between the mean equal to 0? They actually mean the same thing. It's just that depending on the analysis you are doing. If you want to compare whether the two mean are the same, fine. If you want to compare if their difference is equal to 0, fine. So that will be your null hypothesis. When your alternative hypothesis will be that their population mean are not equal. That means there's a difference between the pre-test and the post-test, or the difference between their mean is equal to 0. So this is their formula in case you want to solve it physically. This is the formula you should use, and these are the variables that are contained in the formula. So for the mean hypothesis testing, independent two sample test, the T compares the mean of two measurements taken from two different individuals, object, or related units. This independent sample measurement can represent things like this one. You are measuring two different individuals. In this case, we are comparing the mean of two different populations. For instance, let's say you want to deal with the heights of people in one country and another country, or the scores of people in this school versus the score of people in this school perform better. So that one, you're dealing with two different populations. You're not dealing with one population like in the last example, or neither are you dealing with one population and one score like in the first example we did. So in that case, we use this. Actually, this is the most common case around. And then taking a measurement taken from two different categories in the same population. Let's say in Nigeria, I want to compare the income of workers, whether government workers earn more than private workers. So in this case, it's the same population, but we are dealing with two different categories. So in that same case, we are going to be using this type of analysis. And similar to the first one, what you compare is whether their mean are equal or whether the difference of their mean are equal. Note what I wrote here. They note that each have different hypotheses but the same approach. It's just the same approach. It's just that the hypotheses differ. This is the formula if you want to calculate it physically, and then this is the formula for the S over here. So that's just basically what there is to it. I will not bother giving us examples like all what we did in the last case. we're going to go into the practical section in this video, so I don't want to bore us with all those things. And then one more very important thing I want us to take note of is the living test. Now this living test, let me go statistical a bit. For you to be able to use this paired sample t-test, your data set must satisfy the homogeneity of variance. Let me just read what I have here. Living test is used to test if case samples have equal variance. Equal variance across sample is called homogeneity of variance. Some statistical text examples on paired t-test analysis of variance assume that variance are equal across groups of sample. The living test is used to verify the assumptions. Now, for you to be able to use this thing, you need to pass the living test. That means the samples we are comparing have equal variance, especially this last test, this independent sample t-test. It must satisfy this condition. But if it doesn't satisfy, there is still a test you can perform. Is that okay? But most research, especially if you're doing a standard research, I've been privileged to do some research work even outside the country, and they take some of these things very serious. So I thought to mention it. So if your research, if your variants do not satisfy this condition, there's a test you can use, and if it satisfies, there's another test you can use. I'll show you. It's just that SPSS makes it very easy for us. SPSS, if you run it, it's going to run the living test for you automatically. It's going to check whether it satisfies, and it's going to check whether it satisfies, and any of them that satisfies, it will do 2 of them for you and then show you the one that you are supposed to use. But in other softwares, you might most likely be the one to pick whether you want the one that satisfies or not. They say if the living test is passed, we use t-test sample assuming equal variance. If it is not passed, we use test sample assuming unequal variance. So whatever the case, you use that. But as I said, SPSS makes the work very, very easy for us. So most times, if you want to do this analysis, I would recommend you do it in SPSS, because automatically to do the living test and do these 2 tests here, and then show you the one that is better. So that will be all for our theoretical section, and see you in the practical section. Hello guys, and welcome to the practical section of our class today. And in this section, we are going to be looking at a practical example of what we have done. I remember in the first example, our first video, I did a very thorough explanation of how it feels like to solve it physically. And then this time around, I'm going to be using a software to solve one of the examples. So let's say we want to find out a very, very interesting stuff. Are men taller than women? Remember, this is an authentic data now. Is that okay? It's an authentic data from cargo.com, and the height of all the people in the world. So I want to find out, are men taller than women, generally speaking? Don't you think it's an interesting analysis to try out? Alright, let's try that out quickly. And then we also want to find out, okay, are men taller than women? Okay, which of the 3 type of mean test are we using? Now we are comparing mean now, so that is obviously a mean test. But which of the 3 mean tests are we using? Which of the 3 mean tests are we using? So if you guessed on paired sample t-test, you are correct, because in this case we're dealing with 2 different categories, although they're in the same population, that's the world now, but they are 2 different categories. So what's going to be our null hypothesis? Null hypothesis, obviously, that men and women have equal height, while our alternative hypothesis is going to be that men and women have different height. Alright, let's jump in straight up to what are we going to do next. So the next thing is we're going to calculate our test statistics. Now, there are different ways of doing this in Excel, but I'm going to pick there are about four ways, but I'm going to discuss one or two, and then I will leave you to find out the rest. So let's use this very simple method here, so that I can explain something. So now, if I go down, now remember I told you that we have two types of this test. We have, okay, this is the paired. Obviously, it's not the paired we are using now. Now, remember we have the one of assuming equal variance and assuming unequal variance. Now, that is the bad thing about this one I want to use now. This one is like, it's obvious that we are the ones to decide whether it has equal variance or not. It's not doing the Levin test for us. Although there's a way to do Levin test in Excel, but I will leave you to check that out. But for this case, we are just going to be using, let's assume that they are unequal variance. Let's assume they have unequal variance, and then try that. So our input range for variable 1 is male's height. So I'm going to drag this down. So for me, this one is going to be from here downward. So our hypothesized mean difference, if you want, there are some cases whereby you want to find out if maybe you are saying that the difference between this and this has been proven to be 10. So in that case, you want to test if their difference is 10, you can put it here. But in this case, we are just trying to prove that it's 0. That means we are saying that it's 0. That means male and female have equal, both of them, their heights are equal. So labels in the first row, yes. Then our distance should be in the new worksheet. I will click OK. All right, let's make this to be bigger. All right, so this is what we have here. Now from here, the next thing is, let's interpret our data. The first thing we can see here is our mean. So the mean for male is 173 and that for female is 160. So remember I told you in statistics you can't just conclude like that. So we need to check whether it's statistically significant. Okay, the variance of this is 24 and this, thank God we use unequal variance. I see that the variance are 2 words apart. Then our observations 199, hypothesized mean difference 0. Our degree of freedom is this. Our T statistics, remember T statistics, this is the one T calculated. If you use the normal formula, this is what you calculated. Then this is our p-value. Wow, this our p-value is minus 0.0. That means men are really taller than women because the p-value here is very small. But let's change it to a number so that you can see. The number is 0.00. So it's less than 0.05, and then this for one t-tail test, and this one is for 2 t-tail. Remember that when I was explaining, I said 1 t-tail is directional. That means we are saying men, for this 1 t-tail is saying that men is taller than women. Why this 2 tail is saying that I don't know if men is taller than women is taller. All I know is that both of them are not equal. So if you are just trying to prove they are not equal, you use 2 tail. If you are trying to prove that okay, one is taller than the other one, you use 1 t-tail. All right. So whatever the case, both of them are significant. While this actually here is our so whether you are using p-value or you are using that method I used in that first class that we were checking whether T calculated is greater than T tab. So if you check here, our T calculated and this is our T tab. So our T calculated is T greater than our T tab, and our T calculated here is also greater than our T tab here. So whether we're using p-value, which is this one, or we're using the calculated and the using the whether it's greater than or less than for a T cal and T tab, our result is correct. So in this case we are rejecting our null hypothesis and we're actually agreeing that male are taller than female. Mm. So we're proving it statistically now. So we can go around and say, bros, in this world, men are actually taller than females. It has been proven statistically based on our analysis. So now, are you saying that we're actually doing real life research? Now in real life, you might see some much more complex analysis, but believe me, they all follow the same principle. Some of those very, very big ambiguous analysis, all you just need to do is to crack which analysis am I supposed to use, and the rest becomes easy. So do I use another method? If you understand this method, there are other methods. This adding, I need to send this adding to you guys so that you guys will have this. And here, let me just show you how to use this adding to do it. Uh, where is it? This t-test and non-primary parametric test. So this is where you can do it. So if you come here, so you put your input range here, you put your output range here. You see one sample paired or independent. So in this case, it's independent. It's a t-test, and then you just put in your values, hypothesize mean, alpha value. Remember, I told you the default is always 0.05. You click your OK, and you get much more powerful add-ins. Or even this other add-in here that it's in my Excel, you can still use this and you can still do it. So, but that is just basically what there is to it. I don't want to make this video long, but I believe that I now have some statistical minds here, and I don't need to trouble myself like I did initially. I believe you're beginning to understand the concept gradually, and that is the main thing. It follows a pattern. Even when you get a real life work now and you now want to work on it, even if you don't understand, if you check online one or two things with what you have already gotten in this course, it has built a very good foundation for you so that you can, if you divert a bit, you will be able to understand exactly what's going on there. So let's stop here for this video, and in our next video we're going to be going to variance hypothesis testing. So thank you and bye for now.